The formula for kinetic energy is 1/2 mv squared. And I've written that here to the right on the whiteboard because that's probably the most important thing for this topic. That's also what's written here in the second line under the key concepts on the slide, just as K is equal to 1/2 mv squared, where K stands for kinetic energy for short. Kinetic energy really is the energy of motion. And of course, how do you get an object to move? Well, if it's starting at rest, the thing you could do is apply a force to it. And of course, if you apply a force to it and the object accelerates, well, maybe that force did some work. Can you connect that amount of work to the kinetic energy you gave the object? And the answer is yes. And that's kind of what this formula up here, the first formula, the key concepts page, is about. This is the work kinetic energy theorem, which really, from a very strict point of view, only applies to a situation where you have an object, a force is applied to it, that force changes the object's motion, as it naturally should, following Newton's second law. But as a theorem, it says that if all that is true, the object's change in kinetic energy will equal whatever work that force did. And it turns out, because that you might say, like, well, is that trivial or whatever? But we're going to see maybe in one dimension it's a fairly trivial thing to show. But if you say, okay, but this is going to hold true for any kind of like trajectory, even in 3 dimensions, where maybe it could start with some non-trivial velocity vector or have a force applied to it that maybe is varying and varying in both magnitude and direction. It turns out this theorem will hold for all those as long as it really is just one force changing an object's motion. In that sense, this formula doesn't hold in a lot of real situations. Like if I say, hey, I push a box and I displace at some distance, did the work I did there equal the gain in kinetic energy of the box? And the answer is no, because there was another force, friction, that was influencing that box, and that kind of spoils it. And from an energy point of view, I did transfer energy into the box, but the box also transferred energy into the environment as it created thermal energy due to the sliding. So in that sense, this is a very specific kind of formula that only applies in cases that are not very often the case for objects moving in our environment.